Hi, my name is Hazik, and today I'll explain how to solve a first-order differential equation using Euler's method. I'll also compare it to the exact solution and calculate approximation error at x equals to 1. Let's dive in.
So let's use this example to understand how the method works. Alright. So let's say we have a differential equation such as this dy over dx equals to fsy. We also have an initial point labeled x0 and y0. And our goal is to estimate the values of y at the other points. And Euler's method uses this update formula. Yn plus 1 equals to yn plus hf xn, yn. H being the step size and yn being the current y value. This means that we take the current y value, then add a small change, slope at that point, multiplied by the step size h. In this diagram, the smooth curve represents the actual solution, which we don't know exactly, starting at x0, y0. We compute the slope from the function fx, y. Using this slope and a fixed step size h, we move forward to estimate the next point, x1, y1. The step is calculated using the formula you see here. We repeat this process at each new point to build a piecewise approximation of the curve. The red straight line, the straight line segments are Euler's approximations. The smooth curve represents the true solution. The smaller the step size is, the more accurate the approximation becomes.
We're given the question dy over dx equals to x squared plus 1 over y, which is our IVP, and it asks us to find the approximate value of 1. So if you look at my Excel sheet over here, column A is the step size n, which is an increment of 1. And the next one is the current x value. And I used a 0.1 increment so that we can get an accurate Euler value. And over here, we have the Euler approximation on this column. And here we have the slope, which we can see the value over here of x squared plus 1 over x squared plus 1 over y. And for our last column, we have the next Euler value, which I just added. In this column, I applied Euler's formula over here, which I put d2 plus 0.1 times e2, which is from here, which is yn plus hf times f xn, yn, which is the derivative of the slope, and the step size plus the current y value. So at the end of it, when we get to 1, which the question asked for, we got a approximate value of 1.911375, and that is our Euler's approximation value using the method. For over here, I solved the exact formula to get the solution, and the particular solution is y equals to square root 2x cubed over 3 plus 2x plus 1. And I got this from over here when I solved it regularly. And to find this value, I plugged in the x equals to 1, as you can see over here. So when I did that in this solution here, I got this 1.9149 to 4 decimal places. And I did this as well on here, where I plugged in the value. It's a good way to compare the two. And the approximation error is the actual value from here minus the Euler's value, which we got from here. So which I got 0.003483 SF. Thank you for watching. I hope I helped you understand how Euler's method works and how we can analyze its accuracy. See you in the next one.